Okay, we're into chapter 4 now, and we're going to start with section 4.1, which is on estimating roots. In previous years, we've done some work with square roots, and most of the times you've worked with square roots of whole numbers and rational numbers that were perfect squares. So this chapter, we're going to extend that knowledge to cube roots, and we're also going to look at simplifying different types of radicals. So the first thing we're going to start off is a little bit of a review of square roots. So if you are trying to find the square root of a number which isn't a perfect square, one of the methods you can use to estimate the value, I mean you can always put in your calculator, but we're going to just try to show you a method that you can use just to see if your answer is reasonable, or if you don't have a calculator, what you can do to get an approximation. So if you're estimating the value of the square root of 7, 7 is not a perfect square, but 7 lies between the two perfect squares of 4 and 9. So you would say basically that 7 is between the values, or the perfect squares, uh, 4 and 9. So therefore, you can write it like this: 7 is bigger than 4, but less than 9. That would be a true statement. So therefore, it makes sense that if we're looking for the square root of 7, it should be between the square root of 4 and the square root of 9. So therefore, we know that the square root of 4 is 2, and we know that the square root of 9 is 3. So we know that the square root of 7 is in between 2 and 3. So the square root of 7 lies between 2 and 3. And because 7 is probably considered a little bit, tiny bit closer to 9 than it is to 4, then we would halfway between 2 and 3 would be 2.5, but because, as I said, 7 is a little bit closer to 9, we'd probably go a little bit more than 2.5, and we can do an estimate would be approximately 2.6 maybe. And then you could check that, and I'm just going to, just to speed things up, just going to check 2.6 times 2.6 on my calculator if I want to check. 2.6 times 2.6 gives me 6.76, which is a pretty good estimate. If you wanted to refine that a little bit more, you could say 2.6, maybe 2.64 times 2.64, and that gives me 6.96. So that could be your second guess. All right, so if you are going to extend that rule to cubes, perfect cubes, you can basically estimate the cube root of a number by figuring out which two perfect cubes the number lies between, if the number itself isn't a perfect cube. So 35 does not have is not a perfect cube. So we would have to estimate its value. So 35 lies between these two values here, the perfect cubes of 27 and 64. And then, so that means that the cube root should lie between the cube root of 27 and the cube root of 64. So that would be between, cube root of 27 is 3. 3 and cube root of 64 is 4. So that means that our number, cube root of 35, is a value between 3 and 4. And 35 is a bit closer to 27 than it is to 64. So I'd probably go a little bit less than halfway between 3 and 4. So for example, a good first estimate might be 3.3. So if I just check 3.3 cubed on my calculator, I get 35.93. So when I cube my first answer, I get 3.3 cubed is about 35.937. So 35.937 is not too bad, but it's a little tiny bit over. So if I wanted to refine my estimate, I could probably say something like 3.29 or 3.28. And that gives me 35 point, which gives me 3.28 cubed is 35.287, so on. So that's not too bad. I can probably go a little lower, 3.27 if I wanted to. And 3.27 gives you 34.96, so either one. So, so we talked a little bit about perfect squares and a little bit about perfect cubes, and some numbers are both perfect squares and perfect cubes. For example, 729 can be written as 27 times 27, so that is a perfect square. And 729 can also be written as 9 times 9 times 9, so that means it's a perfect cube as well. So when you're trying to determine if a number is a perfect cube or a perfect square, if it has a nice cube root or a nice square root, there's a couple of things you can do. You can kind of visualize it in terms of a diagram. Anything that's cube root we kind of associate with volume, and when we're using perfect cubes we associate with volume, and then the cube root would be the side length of a cube with that volume. And square roots we associate with area, and the number that we're trying to find, the square root, would be the area, and then the side length of the square would be the square root of that number. So that's one way. So in this case here, we're looking for the cube root of 216. So we think of a volume of a cube with volume 216. So therefore the edge length would be the cube root of 216, which is 6. Whoops. Which is 6. If we wanted to, we could also use a calculator, of course. But if you don't have a calculator, you can also use prime factorization. For example, 216 is going to be divisible by 6. We know that now, but that would be 6 times 36. And then 4 sets, well, you can kind of skip a step in prime factorization because you got 6 times 6 times 6 here. So you don't really need to go down to prime factorization. You can stop right there. You can leave it at, there's obviously 3 6's, so therefore the cube root of 216 is 6. I mean, if you did go down to prime factors, it'd be 2 times 3, 2 times 3, 2 times 3. So obviously you got 3 groups of 2 times 3, which is 3 groups of 6. So the next part here asks you to basically decide, figure out the value of each of the given radicals, and then decide whether or not that would be considered an exact or approximate answer. So the square root of 36, you should know that one off the top of your head, and that should be a value of 6, and that would be exact. The square root of 64 is another one you should know, and that's 8, and that would also be exact. The square root of 625 over 256, you can break that down into the square root of 625 over the square root of 256. And the square root of 625, I believe, is 25. I'm going to check that. And the square root of 256, 16? Yes. So that would be 25 over 16. Which is again the exact answer. I know it's a fraction, but that doesn't mean it's not an exact answer. That is the exact answer. 0.27 is not a perfect square, so if we use our calculator just to save some time, 0.27 comes up as 0.519615, so on. So I'm just going to round that off to 0.52. So that would be approximate. And then the cube root of 0.27, though, would be 0.6446, around there. So that would be, again,'cause we're rounding that off. The cube root of 36, again, is not a perfect cube, so if we use our calculator again to find the cube root of 36, we can estimate that the cube root of 36 would be between 3 and 4, because it's between the perfect cubes of 27 and 64 again, and then approximate, but we're just going to use our calculator now for this. So this ends up again being an answer which is not exact, so we're just going to say approximate again. Next one's cube root of 64, which you should know is 4, so that would be considered exact. And the cube root of 625 over the cube root of, you can break it apart like that again. Cube root of 256. But again, that's not really going to help because the cube root of 625 is 8.54 around there, and the cube root of 256 oh my. Keep hitting the wrong button. Is 6.349 around there. So they're not nice perfect cubes, so if you wanted to, you could simplify 625 over 256 first by going 625 divided by 256 and then cube rooting it, or you can work each one of those out as 8.55 around there over 6.35, and then so that's approximate again, and then 8.55 divided by 6.35 is 1.35. Again, this would be approximate. Next one, cube root of negative 64 would be negative 4, so that would be exact. And the last one, cube root of negative 0.27, would, well, we already found the cube root of positive 0.27 up above, so this should just be the negative of that, because a negative multiplied by itself 3 times will be negative. And that would again be approximate. All right, so now in this question, we have to, most of these ones here are perfect cubes that you should know. So let's try to do this without a calculator. So the cube root of 125 would be 5. The cube root of 343 would be 7, I think. 7 times 7 is 49, and 49 times 7 is 3, carry 6 is 24, 28, sorry, and 6 is 34, yes. So 7 times 7 times 7 would be 343. And the cube root of 512 would have to be something a bit bigger than that. 8 maybe. So if we check that, try to do it without a calculator. So 8 times 8 is 64. 64 times 8 would be 2. And that's 48. And 3 is 51. Yes. Okay, so the cube root of 512 is 8, because 8 times 8 times 8 is 512. And the fourth root of 10,000 would be just 10. Powers of 10, you know, if you multiply 10 by itself 4 times, that would be 1 and 4 zeros. The cube root of 1 is easy, that's just 1, because 1 times itself 3 times is 1. The fourth root of 81 is actually 3. 3 times 3 times 3 times 3 gives you 81. For these ones here, you can break them down into the cube root of the top and the cube root of the bottom. And that would be 2 over 3. Next one, same thing. If you do the same thing, cube root of the top and the cube root of the bottom. I'm just going to write that here. Cube root of 64 over the cube root of 125. And that would be 4 over 5. And the next one, this one here, you could work each of those out, but if you want to do it out of calculator, you could basically take that fraction, and if we just take this off to the side here and think 0.0016 over 0.0081. If we move the decimal place 4 places to the right, basically multiply by 10,000. And this one here, same thing. Move it 4 places to the right. We would end up with the fraction underneath that root sign would be basically 16 over 81. So therefore, we'll be finding the fourth root of 16 over 81, which would be the fourth root of 16 over the fourth root of 81, which is equal to 2 over 3. Let's go fix that a little bit, doesn't look like a 3. Try it again. Oh, won't let me fix it. Okay. All right, so the next question asks you to determine which radicals can be evaluated. So basically, which ones can we come up with real number answers for, answers that make sense. So this one here, the cube root of negative 125, that is negative 5. Because negative 5 times negative 5 times negative 5 will give you negative 125. The square root of negative 27, though, would be undefined in real numbers. Because there is no number which, when multiplied by itself, will give you a negative value. Since there is no number which, when multiplied by itself equals a negative. Okay, so the cube root of negative 1 would be negative 1. And the fifth root of negative 32 would be negative 2. Multiplied by itself 5 times would give you negative 32. But the fourth root of negative 1 again would be undefined, because when you multiply a number by itself an even number of times, the result will always be a positive. A positive multiplied by itself an even number of times will be positive, and a negative multiplied by itself, we've got an even number of negatives, they cancel each other out, and you'll end up with a positive. So there's no number which will multiply by itself 4 times that would give you a negative value. So both of these, for the same reason, the fourth root of negative 81 would be undefined. And this one here, we can break apart the top and the bottom again, and when there's a negative value, you can put the negative with either the top or the bottom. I'm just going to put it with the top for now. And then that would give you negative 2 over 5, or negative 2/5. And this one here again would be undefined. If you try to put these on your calculator, you will get an error message on your calculator, and that's why. And if we do the same method we did for number 2 there, if we multiply the top by 1, 2, 3,000, and the bottom by 1, 2, 3, 1,000, we will end up with the cube root of negative 8 over 27, which would be the cube root of negative 8 over the cube root of 27. Again, I just put the negative with the top, not with both. And then that becomes negative 2 over 3, or negative 2/3. So what rule can you create for determining which radicals can be evaluated? In terms of when all of these numbers in number 3 were negative values, so you can only find the root of a negative number if the index is an odd number. So, so radicals which have a negative radicand, so the number underneath the radical sign, can only be evaluated if the index, which is the number, the little number in the little corner there of the radical sign, so if the index is odd. All right, question number 4 asks you to complete the statement to kind of estimate the value that's being asked. So in this case here it says, since 11 is between 9 and 16, then the square root of 11, which is not an exact number, the square root of 11 should be between the square root of 9 and the square root of 16, which means that root 11 is between 3 and 4. And if you wanted to make a guess for that, 11 is probably a little bit closer, it is a little bit closer to 9 than 16, so I would probably say something like 3.3 or 3.2 as an approximate answer. Since 45 is between 27 and 64, then the cube root of 45 should be between the cube root of 27, which is a perfect cube, and the cube root of 64, which is also a perfect cube. So that again would mean that the cube root of 45 is between 3 and 4. Cube root of 27 is 3, cube root of 64 is 4. And again, 45 is kind of middle of 27 and 64. So you can guess that probably 3.5 or 3.6 or something you could use for an approximation of the cube root of 45. Since 5 is between 1 and 8, then the cube root of 5 would be between the cube root of 1 and the cube root of 8, which is between 1 and 2. And the cube root of 5, again, 5 is probably a little tiny bit closer to 8, but so probably 5.6 maybe, 5.6, 1.6, because halfway would be 1.5, but 5 is a little closer to 8 than it is to 1. So if we just check on the calculator here, the cube root of 5 is actually 1.7. So the next question asks you to arrange the radicals on the number line. Now it asks us to try to do it without using a calculator. So if we look at the fifth root of 200, we know that 2 to the power of 5 is 32, and 3 to the power of 4 is 81, so that means 3 to the power of 5 would be 243. So we know that the answer for A has to be somewhere between 2 and 3. So if we just check that on the calculator, fifth root of 200, we get 2.89 for that, so approximately 2.89. And B, the square root of 20. Well, 20 is in between the perfect squares of 16 and 25, so that means it would be in between 4 and 5. And if we use our calculator, we can get the more accurate answer, 4.5. And the cube root of 45 is in between perfect cubes of 27 and 64, so that would be between 3 and 4. And if we use the calculator again, we get the cube root of 45. Oops. Is right 3.6. And the fourth root of decimal 32, well, that's going to be something pretty small. So if we check that on the calculator, it's going to be less than 1 for sure. Fourth root of 0.32. We get 0.752, so approximately 0.75. And then the cube root of 5, again, that's going to be something between 1 and 2. So if we check that, the fifth root, the cube root of 5, we get 1.7. And the last one, the fourth root of 24, well, 2 to the power of 4 is 16, and 3 to the power of 4 is 81. So we know that's going to be between 2 and 3. So if we check that, fourth root of 24, we get 2.2 around there. So now if we put these down in the right places, we know that the first one, 2.89, would be about here. So I'm just going to put the letter corresponding to that number in there, because it's hard to write small these pens. And then we have B would be the 4.5, which would be around here. C is about 3.6, which would be this one. And D is the 0.75, which would be right about here. And E would be 1.7, so that would be E. And then F would be the 2.2. Okay, so there's some questions on page 206 in your textbook that you can try to practice the material in this section.